Your coding agent has your permissions, and it reads text that strangers wrote. That is the whole vulnerability, and in April, Cursor shipped a fix for 2 bugs that proved it, both rated critical. A poison web page could reach the machine with no click, no download, and no approval past the prompt you would have given it anyway. Here is the part that should bother you. The sandbox was switched on the entire time. The confused deputy. A deputy acts with authority on someone else's behalf. Your agent is a deputy. It holds your file access, your shell, your logged in sessions. Add the second input. The agent also reads pages and tool responses it did not write. To the model, those tokens look exactly like yours. In June 2025, Simon Willison gave the dangerous combination a name, the lethal trifecta: access to private data, exposure to untrusted content, and the ability to communicate externally. His warning was blunt. If your agent combines these 3 features, an attacker can easily trick it into accessing your private data and sending it to that attacker. Any 2 are survivable. All 3 turn one injected prompt into an exfiltration pipeline. Hold that thought. It comes back at the end. How the injection arrives. Here's the path. An attacker writes instructions into a page. It ranks in search. Your agent fetches it, and the instructions land in context. The vulnerability record describes the trigger in 1 clause. No user interaction beyond a benign prompt. You asked for something reasonable. That was the attack. The second doorway is the tool layer. A connected MCP server returns a response, and that response is content the agent reads. This is not a Cursor oversight. The model context protocol specification documents the same surface in its own threat model, including servers that steer clients toward internal addresses and cloud metadata endpoints. Other vendors treat this channel as hostile. Claude Code fetches the web into a separate context window and will not auto-approve curl or get. Escape 1. The working directory. Start with what Cursor did right, because it matters. Before version 3.0, Cursor already ran agent terminal commands inside a sandbox by default. The sandbox granted write access to one place, the working directory of the command being run. That is a reasonable design. It is also where it went wrong. Because the working directory was a parameter on the terminal tool and the agent could set it, point it somewhere sensitive, and the sandbox widens. Read that as a loop and the problem is obvious. The thing being contained is choosing where the wall stands. And the payload writes itself. The most useful file to overwrite is the sandbox enforcer, a helper binary sitting inside the application bundle. Neutralize that, and every command after it runs unsandboxed. NVD spells out the same path in its own description of the bug. Both bugs landed at 9.8 on the CVSS 3.1 scale and 9.3 under version 4. Critical on either. Escape 2. The check that fails open. The second bug is the better lesson. It was fixed in April 2, and you can state it in 1 sentence from the record itself. The check works like this. Resolve the real path. Confirm it is inside the workspace. If resolving fails, trust the path you failed to resolve. The record names 2 ways to force that failure. Point the link at something that does not exist, or strip read permission from a folder. Both are things the agent can do inside the workspace it is already allowed to touch. The attacker never leaves the sandbox to break it. This is a fail open check, the most portable idea here. A security test that cannot finish has 2 options: deny or defer. Deferring is not caution. It is approval with extra steps. Step back and the 2 escapes collapse into 1 trust failure. One trusts a parameter the agent supplied, the other trusts a path it failed to verify. Both are the deputy taking an instruction from the wrong party. Itai Ravia of Cato AI Labs reported both to AnySphere, Cursor's maker, in February. As reported, the first response was a decline on threat model grounds, before the cases were reopened days later. Both were fixed in Cursor 3.0 on the 2nd of April, before any of this was public. When the tool is the attacker. Everything so far assumes a poison message reaching an honest tool. The uglier case is a tool that was never honest. In September 2025, researchers at Koi Security found the first publicly documented malicious MCP server. It was called Postmark-MCP, and it sent email for AI assistance. The patience is the part worth studying. 15 clean releases first. Real code, real trust. The backdoor arrived in version 1.0.16. 1 line. Every email the agent sent was copied to an address the attacker controlled. Koi summary. Every email has an unwanted passenger. The protocol plumbing has been hit too. One critical flaw in MCP tooling, rated 9.6, triggers on exactly what we have been describing. And if you are assuming someone vets these things, read the fine print. Anthropic's own documentation says it reviews connectors against listing criteria before adding them to its directory, but does not security audit or manage any MCP server. A directory listing is not an audit. The vendor says so in writing. Blast radius, and what actually holds. Cato AI Labs, who found the Cursor bugs, put the impact plainly, in wording carried by the Hacker News. Once the sandbox is neutralized, the next command runs as you. That means control of the developer's machine, Plus, any cloud or SaaS workspaces the editor is signed into. Your agent's reach is the attacker's reach. There is no smaller number. Compare the other agent failure everyone saw this month. In July, OpenAI's Codex lead traced a wave of file deletions to a failed variable expansion. The agent pointed home at a temporary directory. The expansion failed silently. A cleanup routine trusted the empty value and deleted the real home directory. That is the whole space. One defeated a sandbox that was on. The other ran with sandboxing off. Beat the control or switch it off. What holds? File system and network isolation. A working directory the agent cannot widen. Fetches that are not auto-approved. Unmatched commands that default to asking. Look at that last one. Fail closed matching is the exact antidote to escape 2. Same decision point, opposite default. That is the whole difference. The trifecta comes back as a budget. Meta's agent's rule of 2. An agent may satisfy at most 2 of 3 properties in a session. Need all 3, and it does not run autonomously. 2 details matter. The limit applies within a session, and a fresh context window resets it. And when all 3 are genuinely needed, Meta's answer is not a better prompt. It is supervision, a human approving, or another reliable means of validation. Anthropic is equally blunt about the ceiling. No system is completely immune to all attacks. So here's the argument. Cursor sandboxed agent commands by default, and lost anyway. One escape let the agent set the boundary. The other let it break the check that enforced one. And Chapter 5 is the same trust problem from the other side, where the tool itself is the attacker. That is the test worth applying to any agent you run. Not whether there is a sandbox, but whether the thing inside it can move the walls or make the guard give up. Both bugs were reported responsibly, fixed in April, and disclosed after the fix. And the pattern is avoidable. Fail-closed defaults and isolated fetches already ship in other agents today. It is the posture that is not yet standard, not the engineering. Every source in the description, including both vulnerability records. Follow InferenceWire for what the AI headlines actually mean.